solving fraction equations by multiplying. Check skills you'll need. Let's take care of numbers 1, 2, and 3 to warm up today. 1, 2, and 3. So the number one rule when you multiply is make sure everything's in fraction form. Everything in fraction form? Good. Then we look diagonally and see if there's anything in common that I can divide both of them by, and there are not here. So straight across, we should just have 7 over 30. Okay? Number 2, a little bit different story. 2 and 22 are both divisible by 2. 1 there, and 9 and 3 are both divisible by 3, so 1 there. 3 over 11. Good. And then finally here, 3 and 15, both divisible by 3. And 7 and 14, both divisible by 7. So we should get 2/5. How many of you got all 3? 2 out of the 3? Okay. All 3? Good. So today, the title is a little bit misleading because you're going to be doing more than just multiplying. In some cases, you'll be multiplying. In some cases, you will be dividing. Now, if it's an equation, what is it that you think of? What word that starts with an O do you think of when you think of equations? Good guess, but opposite. Because in an equation, we need to find out what the variable is. Okay? Whether that variable is x or b or q or whatever. And in order to find that, we need to perform the opposite operation. So in some cases, we'll multiply. Some cases, we'll divide. We'll take care of the multiplication ones first, so that when we get to the division, there is a little twist with that, as you know, because we've done those before. So, for example, we will see a problem like this. X over 2 is equal to a 15. Okay? Now, when solving equations, and we've done a lot of these over the last, handful of months, our variable is x. What is happening to x right now? Thank you. It's being divided by 2. Okay? Because the bar here is another way of showing division. So if x is being divided by 2, the opposite of dividing by 2, so I'm going to multiply both sides by 2. So just bear with me. I'm going to show you why that works. Multiply x over 2, which is written as a fraction. So I'm going to multiply everything has to be in fraction form. There's me multiplying by 2, putting 2 as a fraction. Because if I'm going to multiply by 2, I need to do it to both sides. This here, I don't have to worry about putting in fraction form because it's not a fraction. So if I look here diagonally, 1 times x is just x. X over 1 equals just x. Because all I need to do is find out what x equals. So doing the opposite is going to get x all by itself. 15 times 2 is then 30. How do you know that 30 is your solution? 30 divided by 2 gives you 15. Okay? Or even if you looked at 30 over 2 as being like an improper fraction, right? You'd say 2 goes into 30 15 times with nothing left over. Okay? Try this one. N over 6 is equal to 12. Currently, n is being, right now it's being divided by 6. So the opposite of dividing by 6, it's going to multiply by 6. It's going to isolate the n. 12 times 6, 72. 72 over 6 equals 12. And I saw some of you, which is outstanding, checking it. Does 72 divided by 6 give us the 12? And then indeed you found out that it does. Okay? That's okay until you get used to the process and know that you're doing it right. That's fine. I'd rather you check it. That's the great thing about equations, is that you can always check them and make sure that you're doing them the right way. A over 7 A, what is happening to A? It's being divided by 7. Right now, that's what's happening. So I need to do the opposite of what's happening right now, which is going to be to multiply by 7. A will equal, is 56 divided by 7? 8. Then we're good. Any questions on those kinds of equations? Now, here, I'll write that last one up here. A over 7 is equal to 8. What is the difference from that one to one like this? Is there a difference between this one and this one? What is the difference? In this one, what is happening to your variable? It is being divided, and you had to multiply. Now, when your number, in this case, your number is a fraction, 9/10, when it's jammed right up next to the variable, what operation does that always mean? Multiplication. So if x is now being multiplied by 9/10, the opposite of multiplying by 9/10 is what? We're going to divide by 9/10. That will isolate x, and here is what we have. Dividing by 9/10. So now flash back to last week. We need to put this into fraction form. And if I need to multiply, I need to do what with my 9/10? I need to flip it. So we'll go diagonally, nothing here, but they have 9 in common. Twenty over 1 equals 20. How do you check it? How do you check it? Plug it in. So 9/10 times x, which we say is 20, is supposed to equal 18. So there's 10 there. 9 times 2, 18 over 1 equals 18, just like we said. So sometimes your variable is actually part of the fraction. When your variable is the numerator, you will do what operation? Multiply. When your variable is next to the fraction, you will divide, but you'll ultimately multiply by the reciprocal, which is what you do when you divide with fractions. Okay, let's try another one. 4/5 x is equal to 20. Let's walk through another one. Okay. So what is happening to x? Right now it's being multiplied by 4/5. You see that? So the opposite of multiplying by 4/5, we're going to divide by 4/5. And this step right here is really, really, really important, because we know that we always will flip what we are dividing by. So if you write it out this way, it becomes very clear which one needs to get flipped. Let's put it into fraction form and multiply by its reciprocal, which is then 5/4. 20 and 4 both have 4 in common. There's 5 there and 1. 25 over 1, x equals 25. Okay. right? 7/8 x is equal to 42. Your turn. Okay, what is currently happening to our variable x? When the number is jammed up right next to it with nothing in between, that means multiplication. Since it's an equation, I do the opposite of multiplying, which is I'm going to divide this 42 by 7/8. Once you get to this point right here, it looks like any other problem that you've done where you divide using a fraction. That's it. So if you can get from there to there, you're going to be fine. 42 has to be put into fraction form because I've got this fraction over here. I cannot just divide any numbers I want. That's why I need to multiply by the reciprocal. So 42 and 7 have 7 in common, 6 there, 1 down there. 6 times 8, 48 over 1 equals 48. Why does this make sense? If I have a 48 here, all right, now I'm going to give you one of each. And you will decide what it is you need to do. Yeah. Yeah. Okay, here we go. Sometimes your variable is part of your fraction like it is here. If it's part of the fraction, what's happening right now? P is being divided by 9. The opposite of dividing by 9, multiply by 9. Therefore, P will equal 81. 81 divided by 9 is 9. Sometimes your variable is next to the fraction. In that case, what's happening to P right here, yes, being multiplied by 7/8, so the opposite, divide by 7/8. Once I get there, I should be fine. 21 over 1 times 8, 7. 21 and 7 have 7 in common, 3 and 1. And 24 over 1 is 24. Okay? Now, you know the process. So when you see something like this, r over 12 equals 1.5. There is no reason to freak out. You can only do what the problem gives you. So, just like before, if r is being what? Divided by 12. The opposite will be, so I'm going to multiply by a decimal. Ooh. So all we need to do is multiply with a decimal, and I take care of the decimal all the way at the end. Remember, drop the 0. Okay? With 1 decimal place makes my 180 18. Okay? What is it? Plug it in. 18 over 12. What is 18 over 12? 1.5. What's 1.5 as a decimal? Okay, is it that hard? Seven-eighths B is equal to half. What was this before? It was just a whole number. So what? What are we doing? We're going to divide by... Oh, why? To get b by itself, we do the opposite because b is being multiplied by 7/8. Okay? So all we need to do here, bring down the half, just like I did with that whole number in fraction form, and multiply by the reciprocal. 4/1 equals 4/7. So I get a fraction for a final answer instead of that whole number that I've been used to getting. It's really, the process doesn't change. Worksheet 5-5, take it out. We should have them all. Five-5, 1 through